Hi students, in the last video we discussed about even reactions, even elimination reactions. Now in this video we are discussing E2 elimination reactions. So E2 elimination reactions are bimolecular reactions. Bimolecular reactions, here two molecules will take place in this reactions. So these are bimolecular elimination reactions, and these are mostly attained in the primary alkyl halides. So as we discussed in E1 reactions, tertiary halides will take place in E1 reactions. Here primary alkyl halides will take place in the reactions, and even reactions I told weak base is needed for the reaction to carry out, but here strong base is needed for the reaction to take place, like alcoholic KOH. So the strong bases, why they are needed means to pull the beta hydrogen easily. So why the strong bases are needed? To pull beta hydrogen easily. We already discussed what is beta hydrogen, alpha hydrogen, etc. So let's see one example. I will explain it with one example. CH3, CH2, CH2X. So when we take this, so what happens? This is alpha hydrogen, alpha carbon. This is beta carbon. So first what happens in the presence of a strong base like alcoholic KOH? So this halide will be removed, and so alcoholic KOH will be attacked to the beta carbon or beta hydrogen. So it will form KX plus this K with X, and OH will be OH will be mixed with the H to form H2O, and it will form CH3CH. This H will be removed along with OH to form water and CH. Here the double bond will come with CH2. So like this it will form, and here the alkenes will be formed. So let's discuss what is its mechanism of E2 elimination reactions. So here the nucleophile is provided by KOH, like strong base like KOH. In E1 reactions I told two steps will be there, but here only in one step all the reaction will be completed. So let's take example CH3, the same example CH3, CH2, CH2X. So removal of alkyl halide, so alpha carbon, beta carbon, and the nucleophile is provided with the KOH, so OH minus. So when the reaction takes place, what happens? CH3CH, this H will be removed with OH, so it will be bonded with the OH, so to remove water molecule, and CH2, the living group X halide, the living group will be like this, and this stage is called transition stage. So after this transition state, it will all be acquired in one step only. So OH and H will be removed as water molecule, and X will be removed along with K. So we will get the product CH3 CH double bond CH2 as we discussed before. So like this the mechanism will take place. And what is its molecularity? So molecularity of a E2 reactions is 2, and molecularity of E1 reactions, as I told, it is 1. And how many steps are taking place in this reaction? Only 1. In the E1 reactions 2 steps going on. And the nature of the solvent, when we take, what is the solvent, in which a solvent it will take easily is polar aprotic solvents. polar aprotic solvents it will take. And when we take alkyl halides, so in the E1 reactions, as I discussed, tertiary alkyl halides will take place, but in E1 E2 reactions, primary alkyl halides will be taking place in this reaction. And when we take order of the reaction, so what is the order of the reaction? As we can expect is 2. How? Means rate of the reaction is equal to K. It depends on both the alkyl halide and also on the nucleophile, both. So the order of the reaction is 2. So let's discuss the differences between E1 and E2 reactions. So the difference between E1 and E2 reactions, when we see, so E1 reactions are first order kinetics. So it will follow first order kinetics, and E2 reactions it follow second order kinetics. And E1 reactions it will take place in 2 steps. So as we seen, and in E2 reactions it will take place in only 1 step. So in E1 reactions it requires a weak base, but in E2 reactions it requires strong base. I already explained why it is needed strong base. And E1 reactions, they are unimolecular reactions. It will only depend on the concentration of the substrate. But E2 reactions are bimolecular. It depends on both the substrate and also on the base. Then E1 reactions it forms a carbocation is formed because 2 steps are there. In the first step carbocation is formed, but in E2 reactions it takes place in only 1 step, so nothing is formed, but a transition state is formed. And even reactions takes place in polar protic solvents. So what are polar protic solvents? Examples are water and ethanol. So polar protic solvents are solvents nothing but it can form hydrogen bonds with the substrate. They are called polar protic solvents. So even reactions occur only in the polar protic solvents which can form hydrogen bonds. E2 reactions occur in polar aprotic solvents. What are polar aprotic solvents? Means the solvents which cannot form hydrogen bonds with the substrate. So like acetone, chloroform, etc. So these are the main differences between E1 and E2 reactions. So in the next video, I am going to explain the concepts of Sergev reactions, Hoffman's rule, etc. Thank you.